take your soul.
What up? We're back. 5 days in a row. Is this a new record? I think so. How's it going? I'm very excited for today because we're doing the Big O, baby. We're going through boot.dev, Big O notation, something I've wanted to pay attention to and learn for quite some time, and now we're doing it. It's finally happening. So I got some coffee. Excellent. It's warm, delicious. Got my waters. Oh, I think we're ready to go. So, what's up, YouTube? How you doing? Thanks for slapping in. We're gonna do some Big O notation, but first to start off, we got to see what the old Gemini comes up with for our banner today. They're almost always the same, and they're not very interesting. Probably need a new thing to do, but now it's my habit, so I'm doing it. Oh, what a day. It was supposed to be terrible weather, and it turned out to be pretty nice. Oh, that's not bad. Oh, now it picked Alex Plays Live. Nice. Okay. It always picks a random streamer. I love it. Oh, I'm pumped. I can't wait. I can't wait to do this boot.dev course. I've been very excited for it. And I have also just been loving doing boot.dev again. I've missed it. This is what we're doing. This is what we're going to do today. Big O. We'll give, the few stragglers that may or may not come in just a few minutes. Yo, what's going on in Korea? Thanks, man. Have a good day. You too. Hope you're having a good time. We're going to do some Big O notation if you decide to stick around. Just taking a few minutes, taking in the sights. Anything new and exciting happening in the world? I haven't really been paying too close attention. It's been a busy day. But it's the weekend, almost. Friday. We're almost there. We did it, I think. Oh, I saddled myself with a Friday task of always tidying the house before the weekend. And, don't get me wrong, it's great to have the house clean for the weekend. But, what a nightmare to get off work and then go do a house clean. What a bad choice. Don't listen to me on choosing times for your chores. It's I don't have good track records there. Because then all I do is spend all day trying to figure out if I can get out of it. Realizing that I can't, and I'm definitely going to have to do it. What are you going to do? Oh, I'm very excited. I'm going to get started really quick because I'm so pumped. But I just, give some people a few chances. Just talk to the audience. What's happening? Thanks everybody subscribing, by the way. Nothing much. Cherry blossom season ended, so scorching summer is coming up. Oh, man. Yeah, that's a rough one. I am such a winter person. It's kind of embarrassing. I have allergies, so spring and summer are just my nightmare. It's horrible. I mean, I like the nice weather. It is nice when it's warm out, but also it kills me. Going outside just lays me up. But the cherry blossoms were probably awesome. We have some cherry blossoms in Canada, in Toronto, and everybody just swarms to watch them when they bloom every year. I didn't get a chance to go this year. I actually haven't been in a long time. It is fun, but it's crowded because everybody goes. Because it's the one spot that people go to. So my wife actually did a teaching exchange in Korea before we had ever met, but I have yet to go one day. So many places on the list. So many places on the list. All right. Let's see. Hold up. I'm just checking a few random things on all of my other devices that are connected, making sure this stuff works. And then we'll jump into it. Oh, we got Sloppy J coming in. Here we go. Hold up. Oh, oops. That's not helping. I'm trying to type in a different spot. Hold on. Oh my gosh, what am I doing? I'm really good at this, by the way. The other day I streamed, and you can see it on YouTube because I thought it was funny, but I streamed for like 15 minutes. I didn't realize my mic had died. So I just turned it into a silent movie. It was awesome. Hold on, let me share this link. TV/ThoughtlessLabs. Come on in, my man. I promise I won't curse in chat. So I'm reading a Twitter message. I really should remember to do stuff on screen so that people can actually see it. I feel like that's a better way to be. But hey, what are you gonna do? Okay, we're getting close. We are almost ready to start it. You know, I think we gave people enough time to flood in. So I think we should give the people what they want, which is me learning the code and doing terribly at it. You know, I might play some video games at the very end of this if you're into that sort of thing, but we'll see. I get kind of hooked into the old boot.dev, and then I just don't want to do anything else. So, anyways, I'm so there. What up, dude? It's funny. It was such a cold day today. That's why I'm rocking a sweater. But it's actually getting kind of warm this afternoon. We'll see what happens. Okay. What do you think? Should we get on to some Big O? I'm ready. Are you ready? Nobody should be ready for this. All right, let's do it. Actually, let me do one quick thing because I just realized I forgot to do it. And then we're jumping in. Okay. Let me just close this out. Boom. Closing. 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 So many things. Oh my gosh. Out of control. Bump, 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 bump. Bump, bump, bump. Bump, 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 bump. Bump, bump. Bump, 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 bump. Bump, bump, bump. Bump, bump, bump. Okay. We're back. We're ready. We're rocking. I'm ready now. All right, Big O. I'm going to leave the... Hey, Sloppy J in the house. Also, thank you for the follow. I noticed you did it at the end of the stream yesterday. Appreciate it, bro. 74. I can't believe I'm up to 74. And what was I at in YouTube yesterday? I just checked the other day. I was getting up there. Looking good, feeling good. What did we get to? Getting up there for me is like, I never thought I'd get more than 10 followers. So, oh yeah, 122 followers on YouTube. What? What? But look, here, I'll just show you because it's funnier. Hold on. Let me open this up. Look, this is how good I am at streaming or posting videos. Look at that video. 1 hour, 0 views, 0 comments, 0 likes. I tell you, Mr. Beast, you better watch out, son. I'm coming for you, dog. Oh, shit. Okay, anyways. I just wanted to show because it's hilarious. This stupid short is getting a ton of videos, of course, because it's AI related. I mean, a ton of views for me. But it's so annoying that those are the ones that do well. Okay. We're doing it. We're into it. We are Big Owen. All right. So, if you haven't been in the stream before, get ready to watch me read and answer questions and forget how to program and then do it really poorly. And that's about it. Oh, and get distracted a lot and jump around to a bunch of different stuff constantly, because that's my style. Whoo! I tell ya. All right. I don't know why I'm in such a good mood today, but I'm pumped. Okay, here we go. I can't decide if music on in the background is better or not. I'm gonna leave it now. Oh, Bash is streaming. Yeah, Bash Bunny's streaming. I like Bash. She's cool. I've never met her. I don't know her personally. I'm just saying I like her streams, and she's cool. And you should probably go watch her. That's what I would do. But but you're here with me. Okay, here we go. There are a big O notation. Let's do it. There are a lot of existing algorithms. Some are fast and some are slow. Some use lots of memory. It can be hard to decide which algorithm is the best to solve a particular problem. Big O analysis, pronounced Big O, not Big Zero, which is only funny because I guess the O kind of looks like a zero sometimes, depending on the font, because it's very clearly an O. So I don't know why anyone would call it a zero. I don't know. Is one way to compare the practicality of algorithms by classifying their time complexity. Big O is a characterization of algorithms according to their worst case growth rates. We write Big O notation like this. O formula inside parentheses, where formula describes how an algorithm's runtime or space requirements grow as the input size grows. So O of 1 is constant. O of log n, log base n, is logarithmic. O of n is linear. O of n squared is squared. O of 2 to the n is exponential. And O of n factorial is factorial. And for those of you who did not join us yesterday, we were learning all about the differences between those things. And this Big O complexity chart seems to showcase all of the stuff we were talking about yesterday. The following chart shows the growth rate of several different Big O categories. The size of the input is shown on the x-axis and how long the algorithm will take to complete its show. Oh my god, sometimes I can't read sentences. The following chart, let's try this again. Okay, let me try and read this properly. The following chart shows the growth rate of several different Big O categories. The size of the input is shown on the x-axis, and how long the algorithm will take to complete is shown on the y-axis. There it is, in all of its glory. So you can see O factorial is the worst, and the best is O of 1 or O... Wait, is O of 1 the best, and O of log n is the second best? Is that right? I think so. Because they're not the same. Are they the same? Is that a comma? Are they the same? I don't know what Lane's trying to do here on this chart. I know it's not even his chart, but we're going to keep going. All right. As the size of the input grows, the algorithms become slower to complete, take longer to run. The rate at which they become slower is defined by their Big O category. For example, O of n algorithm slow. O of 1 is constant. O of n is depending on the number of elements. Ah, right. Nightshade dude coming in with the real knowledge. So O log n could be faster. I like Nightshade dude coming in and helping me out here. But wait, what about O log of n? That's what I was really confused about. That's what I meant to say. I think I kept saying O of n. But are O of log of n and O of 1 the same? Because I just don't like how this chart has a comma. It makes it confusing to me. My little pedestrian brain. No. So then what is up with that comma, Nightshade dude? I don't understand it. Did you know that you were going to have to come in and do some more teaching? Maybe the video will explain it. We'll get to Lane's video. Then you don't have to be the one explaining everything. Let me finish this paragraph before I forget. As the size of inputs grows, the algorithms become slower to complete, take longer to run. The rate at which they become slower is defined by their big O category. For example, O of n algorithms slow down more slowly than O of n squared. All right, Lane, let's see what you got. I hope you explain that comma to me, because I don't know it. I'm turning off the tunage. Hold up, folks. Oh, did this video not load? I gotta reload the page. Hold up. There we go. Oh, 8 minutes. Are we gonna watch an 8-minute video? This is the longest video. All right, we're doing it. 8-minute video. Let's go. Sweet. I can take a break. I've already been doing this for like 15 minutes. I'm exhausted.
Big O analysis is just a way for us as computer scientists and programmers to categorize different algorithms by how they slow down as the input size to the algorithm grows. Like, super roughly speaking,
Does my
it's a way for us
spacebar
to
pause?
talk about how slow or how
What if I'm
fast
doing this?
algorithms
No.
can run. And to be very specific, we're worried about the worst case runtime. So, for example, if I pass 100 items into this algorithm and I expect it to take 100 seconds to complete, what's the worst case scenario for when I pass in 10,000 items? How does it get worse as the input size grows? That's what Big O analysis is all about. Take a look at this calculate product function. As input, it takes a list of numbers. And for the sake of argument, this is completely made up, but for the sake of this example, let's pretend that these lines take 2 nanoseconds to execute. And assuming that the list of numbers we pass in has just a single item in it, let's assume that these lines of code, the iteration and multiplication, takes just 1 nanosecond to compute. So we pass one item, say the number 5, into this function, it executes, we get a result. Let's just say the total there takes 3 nanoseconds. Great. Now what happens if there's 5 items? Well, these lines of code, we actually still expect to just take 2 nanoseconds because they don't care about the size of the list that's coming into the function. But if one item took 1
That's actually really interesting. A very clean chart. Shitty dev to link. Sorry, hold on. Okay. I will say that is a lot clearer. I like that chart more. Okay. Like, I will say, mostly everything made sense. I just didn't get the bottom part of that other chart. So this is good. I like it. Okay. Now, this is interesting, though, and it kind of makes sense. But you can have as long of a list as you want. And because all it's checking for is that there's nothing in the list, it doesn't change the time. I guess, like, that makes sense, but that's kind of cool.
Nanosecond, it stands to reason that this iterative loop is now going to loop 5 times and take about 5 times as long, so 5 nanoseconds, leading to a total runtime now of 7 nanoseconds. Great. What happens now if we pass 10,000 items into the function? Well, again, these lines of code will still take about 2 nanoseconds because they don't care about the size. But the loop is going to take about 10,000 nanoseconds. So we're talking about a total runtime of 10,002 nanoseconds. So all this to say, this function has a big O categorization of order n, linear time, because the amount of time it takes to run the function is linearly proportional to the input size, the size of the list coming into the function.
Right.
If 1,000 items takes about 1,000 seconds.
All right, that makes sense. I think that's pretty straightforward. I'm on board with this so far. All right. You know what's something that I'm interested in, and I think we'll probably get to, at least ideally, is I've always wondered, like, I've never actually done it, but actually how you implement the tests for seeing how long that stuff takes. Because I've never actually done, I mean, I've never coded anything for anybody where it mattered. But I've always been interested in actually like putting those tests into something to actually see how long things take and play around with optimization of that kind of stuff. So hopefully we will get to do that in this, not in this lesson 1, but like in this data structures and algorithms section of boot.dev. If we do that, I will be stoked.
A million
Benchmark
items
app.
is gonna
Yeah,
take
exactly. I
about
want a
a million
benchmark app.
seconds.
Let's do
Let's
it.
take a look at another example. This function, just called length, takes a list object as input. And it's important to understand this is an object because we're just going to assume that this object has a property on it called object size, and that property is just stored in memory.
Benchmarks
and it's
lie, sorry.
incremented and decremented by other pieces of code whenever we append or pop from the list. The point is it's pre-computed. So our little algorithm here that returns it doesn't have to do any additional math. Now with this function, if we pass in a list with one item, we'd expect just making numbers up here. It's gonna take about 1 nanosecond to return that property back. Great, what happens if there's 100 items in the list? Well,
What does
we're
happen,
just
Lane?
using a static property that's been pre-computed in memory. So it's just taking whatever time it takes to return that field from the function. It's probably just like a memory copy. And so
is this going to be a O of 1 algorithm?
it'll still probably take about 1 nanosecond. If we have 10 million items, again, we're just returning a single number. So it's going to take about 1 nanosecond. So this algorithm, the time it takes to execute actually is constant no matter what the input size of the list is. So this is order 1 or constant time. It's the fastest Big O categorization, or at least the Big O categorization that doesn't grow at all as the input size grows. Now let's take a look at this get full name.
Sloppy J, you settle down over there. Just because it's in the hand of marketers, it doesn't mean that we make it lie. I mean, we do, but not lie, just presented in a much better way. in the most favorable way possible. That's our job. That's what we do. I'm sorry. Actually, just for what it's worth, I actually disagree with most of that sort of tactic, and I think the best thing to do is just be as honest and build a good product. I'm just saying, if we make it, it won't be biased. You're right. I mean, who knows? All right.
Function. It takes 2 lists as input, first names and last names. And we're just going to define n as the length of both lists and kind of just assert that both these lists always have the exact same length. It's going to create a new empty list called full names and then iterate over all the first names, and for each first name, iterate over every last name, creating all the possible combinations and returning those combinations from the function. So again, for the sake of argument, we'll just assume that if there's 1 first name and 1 last name, that means there's 1 iteration of both loops, and it will take about 1 nanosecond to return that single combination of first name, last name. But what happens if there's 2 first names and 2 last names? Well, now we're not talking about
We're going
2
exponential,
iterations.
aren't we?
We're talking about 2 iterations of the outer loop and 2 iterations of the inner loop for each iteration of the outer loop. So now it's actually 2 times 2. So we'd expect a total of 4 nanoseconds. And what if we bump n up to 3? 3 first names and 3 last names. Now we're talking about 3 iterations of the outer loop, and for each iteration of the outer loop, 3 nested iterations. So 9 total iterations, 9 total full names, which means about 9 nanoseconds to run this algorithm.
Sounds
so
like
this one actually gets really slow as we start to increase n. With an n of 100, we're talking about 10,000 total iterations, 10,000 total combinations of full names that we're going to be returning. So you get this kind of parabolic growth in the runtime of the algorithm as the lists get larger and larger. Generally speaking, we try to avoid n-squared algorithms in our code.
Okay, so hold on. Just to make sure, there's an n-squared algorithm and an exponential algorithm. And obviously, yes, so exponential is much worse.
Where possible. They can do okay on like really small input sizes, but as the inputs get big, they can get hairy very quickly. Now, I'm not going to show you the code
I
for
said
this
exponential,
one.
but
There's
this
a
is a squared one.
famous
I knew what I was talking
algorithm
about. I'm
called
just an idiot.
binary search. And basically what it does, in a nutshell, it takes a giant list, let's say 1,000 items, and it's searching for a specific item within the list. And what it can do is at each iteration, chop the list in half.
Yeah.
So for a list of 4 items, we'd chop it in half to 2, and then chop it in half to 1. 2 total iterations. A list size of 8, we'd chop it in half to 4, then 2, then 1. 3 total iterations. A list of 16 items, chop it in half to 8, then 4, then 2, then 1. Only 4 iterations to handle 16 items. With a list of 1 million items, it would only take about 20 iterations to cut this thing down to size. Logarithmic algorithms grow incredibly slowly. Technically, they're not as fast as constant time algorithms, order 1, which don't grow at all. With a log n algorithm and an input size of 1 million items, we're talking about 20 iterations. Well, if we bump that up to 10 million, we're just talking about a couple more iterations. It really like 22 iterations or something like that. I can't do the math off the top of my head.
Oh, yeah, that's wild.
The point is, these input sizes can get absolutely massive, right? 1 trillion items coming into the list. We're talking about like what, 30 iterations maybe? So for practical purposes, you can think about log n as almost as fast as constant time. And the final complexity class we're going to brush on briefly is the exponential class, or order 2 to the n. These algorithms get so slow so quickly that they're basically never practical for real world use. Even just an n of 15, an input size of 15 items, you're talking about computing out to like 30,000 plus iterations. Once n is 30, you can forget about it. These things will take so long to calculate that it's never going to happen. In fact, cybersecurity actually kind of depends on the fact that some of these algorithms are
that's what I was gonna say. That's what I was assuming he was gonna say next. Was that, like, obviously for cybersecurity, you want functions that will do ridiculous things like that. My beloved. Yeah, do you do cybersecurity? I don't even know, Nightshade. I have no idea. But that's wild. That jumps up so fast. I love it. I'm going to write only functions. Oh, God, no. I'm an idiot. Hey, welcome to the club. You're in the right spot. I don't believe you, but you're still in the right spot. Yeah, that's wild. That's super interesting.
Slow, because that means you won't be able to try all the possible combinations in a reasonable amount of time. So these are the main complexity classes to worry about. Order 1 or constant is the fastest. Order log n, almost as fast as constant time. Order n or linear time. Order n squared, much slower than linear time. Technically, you also got order n cubed, order n to the 4th that are even slower. And then exponential time, or order 2 to the n, that is impossibly slow. Even with small numbers of n, your algorithm is going to take so long to run that it's never going to be practical.
All right, that was cool. That's interesting. The worst big O category. The algorithms that slow down the fastest in our chart are the factorial and exponential algorithms, or O factorial and O exponential. How would you say O? How would you actually say that? Would you say O 2 to the n, or would you say O exponential? Because, like, O factorial sounds nice. But who knows? Okay, which of these algorithms tends to run the slowest of these? Booyah, number 1. Easy. Easy. Are we basically experts? Probably. O n squared? Okay, that makes sense. O n squared. But O n squared would just be, like, that one would be O n squared. But what would it be when it's like the O? What would this one be? How would you say this one? Would you say O 2 to the n, or just O exponential, or O what? Oh my, oh me, oh my. Why did you build that algorithm? Is that what you say? oh darn, you picked the wrong algorithm? Is that, I think that's probably it. That sounds accurate. Probably just exponential? All right. Exponential. We can do that. Next question. If you have that algo, you're in trouble. Yeah, that's is if you have that algorithm, you just call it, oh, I'm out of a job. Is that man, I wish I didn't laugh so hard at my own jokes, but I find myself absolutely hilarious. Okay. Order n is very common when the number of steps in an algorithm grows at the same rate as its input size. It's classified as O to the n. O to the n. What was that actually called? See, this is how bad I am at life. What was that actually called? Oh, linear. Locking it in the noggin for like 3 seconds. I've already forgot. For example, our find min algorithm from earlier is O to the n. Set min 1. Set min to positive infinity. 2. For each number in the list, compare it to min. If it is smaller, set min to that number. 3. Min is now set to the smallest number in the list. The input of the find min algorithm is a list of size n. Because we loop over each item in the input once, we add 1 step to our algorithm for each item in our list. As we use find min with larger and larger inputs, the length of time it takes to execute the function grows at a steady linear pace. We can reasonably estimate the time it will take to run based on a previous measurement. If we find that input size, find min 10 items, takes 2 milliseconds, then we can estimate find min of 100 items is 20 milliseconds, 1,000 is 200, 10,000 is 2,000. Makes sense. Hold on, what did you say to Nightshade? So do you know what you were saying or not, Nightshade? Dude, Nightshade dude is hilarious. He cracks me up. Assignment. Locked in users want. Wait, what am I doing? Oh yeah, locked in. I was fudge, man. I hate my brain. I forgot that the name of this whole like chapter and the fake project we were making was called Locked In. And so I was like, what's happening? Okay, locked in users want to know which of their followers has the highest engagement score. Complete the find max function. It should take a list of integers and return the largest value in the list. The runtime complexity, aka big O, of this function should be O(n). Okay. So that should be fairly straightforward. Let's see what we can do. Hold on. We need our music back if we're going to be... Okay. So, taking Nightshade Dude's advice from last time and remembering to reread my instructions so that I don't miss the easiest, simplest, dumbest thing to miss in the entire world. All right, we're going to reread them just quickly. We're completing the find max function. It should take a list of integers and return the largest value in the list. Okay, so we're just doing the opposite of find min. So for that, we need to set max to 0, right? Or are you supposed to set it? Is there like negative infinity? Is that what you're actually supposed to do? Because if it's a negative number, yeah, see, oh, don't exclude negative values from the result. I didn't read already. Shit. Okay. So is it like negative infinity? Is that a Python thing where you can do like this? Or how did I do that last time? There's like int. Is it like this? Or negative int? Is that it? I bet that's it. What happens if I do this? This is how we test. Well, I don't know what it did. Oh, it didn't like that. Invalid literal for int. Fine. So that didn't work. What about... Can I do this? Well, it doesn't like that. Let's find out anyways. Nope. Okay, wait, just to make sure. If I do that, that is a thing, right? Was it... How did I do that last time? Should I go back? I know... I feel like that's what I need to do, though. I'm pretty sure that's right, is that it's something to do with, like, negative int infinity. Here, watch. We can go back to lessons. Boom. Where was it? Oh, I should do this faster. It was... Oh, I don't remember. Nope, that's the one I did poorly. Was it algorithms intro? Yeah, 5 minimum. Oh, I don't have the answer showing up, but I did this one. Whatever. Oh, float inf. Okay, so I think I can do negative float inf. I think. I'm going to try that. I think I can. Can I do this? Whoops. Negative float inf. Is it like that? Oh, that just printed negative inf. Does that work? Does that still work? What does it do if you do the normal one? What does it actually print? I've never looked. Does it just print the string inf? Is that all it does? Oh. Oh, so you're just like faking it out. So does negative even matter? Does it have to be negative? Let me try something. What if I do this? If I do... Wait. When I did this, did it actually do it as negative? If I do... and I just do number equals 5. And I want to know... Can you do print... What are the... No, wait. What am I trying to do? I'm making up a whole bunch of stupid things that aren't even the problem, but I just wanted to try something. So if number is greater than... No, wait. Let's do less than max. Print yay. And else print nay. That's cool. Okay, so that's what it does. I've never actually messed around with that, so that should print yay, right? Cool. I didn't know that. I never looked into it. It just said do this. So I'm pretty sure I'm right on this. Oh, let's test. I can do a negative number. -5 should be greater than max still, right? Yeah. What about -5, whatever that is? Wait, is greater than max. That's right. Okay, perfect. All right, so that's good. And wait, just to make sure, if I say less than, that should be nay. Heck yeah. Dude, math. Math, science, history. All right, so now that we know how to write that properly, then now we just need to do our for num in nums. If... Or is there... I'm sure there's a better way, a faster way to do this. I don't care. I'm doing it this way. If num is greater than max, then max equals num. Right? I think that's all we have to do. And then return max. I think that'll do it. Yeah! I know that for everyone else in the world who does coding on any sort of regular basis, they're like, yeah, bro, this is super easy. But for me, man, I can't believe I'm even remembering half of this stuff. I do such a little amount of coding on any given day. I'm kind of blown away that I even remembered any of this. It's kind of awesome. Okay. What is there a better way to do it? Well, let's do the submit first, just to make sure. Dance break. Oh, So good. All right. What's the solution? And we did the solution perfectly. Oh, hilarious though. I didn't think to do negative inf like that. I just did it the negative out front. I don't know which way is better or if it matters. But anyways, there we go. Sweet, man. Next. Looking good, feeling good, as they say. Next. All right, what are we doing? Reading. Order n squared. All right. Oh, snap. All right. Oh, wait, do people say order n squared? Is that like is that how you actually say it? Or do people say O of n squared? We'll find out. Maybe one day. I'm going to say O of n squared because I want to. Grows in complexity much more rapidly. That said, for small and medium input sizes, these algorithms can still be very useful. A common reason an algorithm falls into O of n squared is by using a nested loop, where the number of iterations of each loop is equal to the number of items in the input. All right. So the example for person 1 in persons, for person 2 in persons, every combination of people will go on a date twice. Runs a function, go on date person 1, person 2. And that way it runs through everybody. But it runs through everybody twice. Got it. Assignment. Locked in needs search capabilities. For now, we'll build something slow and frankly awful so we can see an n to the n squared. What did I say I was going to call it? n squared. N squared algorithm in practice. Complete the does name exist function. So we're going to follow these steps slowly, but I'm going to read them through first. For each first name in first name, for each last name in last name. Oh yeah, it just gave me the function. If a first/last name combination joined with a space matches the full name, it should return true. If the loop finishes, it should return false. When you run your completed code, notice how each successive call to does name exist takes quite a bit longer. Assuming the length of first names and last names is the same, each new name doesn't add n steps to the algorithm. The total number of steps grows quadratically, with the size of the input making the total work O n squared. If does name exist has 10 names and 10 names, takes just 1 second to complete, then we can estimate 100 names will take 100 seconds. 1,000 names each will take 10,000 seconds. And wait, is this right? That's wild. I don't know why. 1,000 names takes 10,000 seconds, and 10,000 names take 1,000,000 seconds. Why is this only 100? Is that just because I don't know how math works? Oh, because this, oh, yeah, right, because this only takes 1 second. Now I got it. I think I understand it, because it's quadratic, so it's growing exponentially. Yes, that makes sense, right? If it doesn't, and I don't know what I'm talking about, that is normal. Do not be alarmed. Just enjoy it. Relax. Have fun. We're all in this together. Okay. What time is it? We're doing this. So now we're just going to go back and basically we're just doing this function as Lane already wrote it out for us, but we're going to write it as code. So we need to do for first in first names, for second, or we'll do last. Last in last names. So we need to do if. Do we have to combine them first? We probably should, right? So we need to do we need our full name, but we don't want to take the full name. I guess we can just do this, right? If first, can we do this? Can I do first name, or can I do first? Can I do this? Can I do first plus space plus last equals full name? Oops. Does that work? We're gonna find out. We're gonna find out. Return true. If the loop finishes, it's return false. That means we have to return false here. Or here. Well, let's just see what happens. Hey, well, that's two trues, though. Is that right? But am I doing this right? Does it return false if it comes down? If the loop finishes, it's return false. Yeah, okay. I think this is right. Okay, should we try it? Worst case, we get it wrong and we make some adjustments. I'm just worried about this return false. But that makes sense. I think it's going over the whole loop. Okay, let's try. Oh, look how long it's taking. Boom. We did it. I can't believe that. I wasn't sure if that first plus space was going to work. All right, what's lane or solution? Oh, what did I do differently? Oh, nothing really. Oh, that's the F literal. That's smart. But other than that, we did basically the exact same thing. Oh no, NST's mod here too. Nightshade dude was mod here before he even had started following me. Classic. Nightshade dude is the best mod. I love having Nightshade dude as a mod. He's hilarious. We're doing some big O, Nil Pointer. Having a good time. Just got this last one right, baby. Woo! We're crushing it. And now we move on to the next one. Also, I need to check the time. I don't know how long we're going to be here today. There's so many things happening because it's the weekend, you know? All right. Okay. N squared quiz. Refer to the following functions and assume that first names and last names are the same length. Okay. So the function print names 1 is first names. You get for first name and first names, print first name. Okay. For print names 2, this has 2 names. You're doing a double loop. So what are the big O complexities of print names 1 and print names 2? So print names 1 is going to be O of N. And print names 2 is going to be O of N squared. Correct? Yeah! Woohoo! Nil Pointer, also correct. Good job. I always forget to let people guess. Mostly because I don't want you, give me the right answer. I'm trying to learn here. I'm just kidding. I love when you're giving me answers. All the time. All right, what's next? Which function will finish faster, assuming first names and last names are the same non-zero length? 1 should finish faster. I'm sorry. Would anybody like to make their guess? I was going to pick 2. If anybody has a different suggestion, let me know, and then we will continue. 3. I think you're right. Let me press 3. Nope. Sorry. Good try. It's a good try. All right, I'm going with 2. Not print names 2, answer 2. Oh, it's just too good. What's next? Oh boy, I get too cocky. I'm in trouble. I can already feel it. All right. O(n) of m is very similar to O(n) squared, but instead of a single input that we care about, there are 2. If n and m increase at the same rate, then O(n)m is effectively the same as O(n) squared. However, if n or m increases faster or slower, then it's useful to track their complexity separately. All right. I hate spring. I mean, I like the weather, but the allergies are killing me. Assignment. Locked In needs a new tool. Needs a new tool that allows big brands to see how many of an influencer's followers are loyal to their brand. Complete the Get Average Brand Followers function. It takes 2 inputs. All handles, a 2-dimensional list or list of lists of strings representing user handles on a per influencer basis. I talked about this yesterday, and I just I don't know why, but when I read that, every time I read stuff like this, my brain just shuts down. It's so bad. I'm sitting here trying to pay attention, and my brain's just yeah, you don't really need to know what's happening. Just say the words, silly man. I'm not gonna pay attention, so that's what happens to my brain while I'm doing the reading. It's so dumb. It's very frustrating. Oh, Prime's doing a live event soon. Well, if anyone stays around with me until I'm done, I will raid Prime because he needs it. Prime needs the support, you know? But I'm sure they're doing a cool event in React, Miami. And they need our support. He's just a small channel trying to grow. Okay. I already forgot what I read. A 2-dimensional list or list of lists of strings representing user handles on a per influencer basis. Okay, so there's a list of influencers, and inside that list of it, for each influencer, there's a list of strings of the handles that follow them, I'm assuming, and brand name a string. Okay. I see what they're trying to do. So one of these lists grows faster, or one of these variables in our algorithm grows faster, which is why we are doing this O(n) of m. What? No, that's not right. O(n)m. Okay. So Get Average Brand Followers returns the average number of handles that contain the brand name across all the lists. Each list represents the audience of a single influencer. So, example, input, output. Input, all handles equal, that's the list, brand name, Cosmo. Oh, I see. So yeah, so this is a single influencer. So that's the list for that influencer. Those are all the followers inside that list. Okay, got it. Expected output 1.33 handles per influencer because 4 handles contain Cosmo and there are 3 lists. Oh, I'm an idiot. I see now. I read that wrong. Now I missed the commas in between the lists. Now I get it. Okay, we're back into it. Observe Big O. Regarding Big O, the number of influencers, the number of lists matters. That's our N. However, the average number of followers of each influencer, the average length of the list is just as important. That's our M. Okay. So, what are we actually trying to do? So we need to return the average number of handles that contain the brand name across all of the lists. Each list represents the audience of a single influencer. Okay, so now, the thing that I know or I feel confident that I'm going to have to do is a string comparison for the brand name in the handle. And I don't remember how to do that. Wait, can you do this in Python? If Cosmo in Cosmo fan print yes. Oops. Oh, can you do that? Oh, you can. Okay. Well, that's a lot easier. Good old Python. Okay, now wait though. Does it find it anywhere? Fan Cosmo. Yes. Okay. I can't, like, dude, where did that come from in this dumb brain? It's somewhere floating way back there. Okay. So we need to do, we're gonna need, it returns the average number of followers. Okay, so I'm just gonna write I'm gonna write the part that I know. So for handle in handles, if, all handles, if brand name in handle, then we're gonna need to total this, right? Because then we're gonna have to do excuse me, then we're gonna have to do the average. So we need a number. Total, what does it want it back? Each list represents returns the average number of handles that contain the brand name. And it wants, does it want per influencer? Anyways, let's just try and get this to work first. So we need, if brand name and handle, then add total, let's do that. Plus equals 1. So we need and we want a total for each. So we should really do total equals 0 inside of here, right? And then when this is done, then we want, because wait, because 4 handles contain Cosmos and there are 3 lists. So our average at the end of the day is going to be, we're actually going to be returning the length of all handles, I think, right? Length of all handles divided by, oh no, opposite way. The total, not total though. Oh no, I guess I don't need to do this because I just need the total. So I'm being silly. We'll just do this though. We'll do total divided by length of all handles. And I really want this total to actually, I do want this to be the total of everything equals 0. Is that right? Whoop. No, what did I mess up? Is this wrong? Does this not actually work? Oh, do I have to return the total here? No. Do I? What happens if I do this? 0. Oh. Because I'm doing this wrong. What an idiot. What an idiot. All right, what is actually happening here? If I print brand name, why did that work before? Because it knew, oh, do I have to do, hold up, I got an idea. Oh, it's not doing anything. Because I'm not, is it because I'm not returning something? I hate when I do this. Or is it just because this is wrong? Hold up. Let's go slower. Slow down, Johnny boy. Okay. Will that actually print what I want? No, because I'm not actually doing anything. For handle and handles. Let me just check this out. Print handle. Is that working? Yes. Okay, good. Oh, there's so many. Okay. Oh, because that's a list. So I need to do, wait. It's returning it as a list. Handle is a list because it's each one. So I need to do, do I need to do another for loop? Wait. I need to check each of these. So hold on, friends. We're getting there. We're getting there. So that's printing out a list. That's good. We knew that. We should have known that. And so what I need to do with that list, I need to check each one, right? So do I need to do for, we'll just call it follower in handle, if follower equals brand name, then we do our total plus equals 1, right? Now I just want to see, will this give me the right thing? Will this give me something? Oh, shoot. No. Because why? I need to return total? Do I have to do that? Whoop. Or am I just still wrong here? Let's do this. Print follower. This is how I do things because I don't know what I'm doing yet. And I'm slow. Okay. But this is how we figured out. Okay, good. That's what I wanted. I wanted it to print those. It's hilarious though. I'm doing a horrible algorithm that's going super slow because it's checking everything. Okay, so we're just gonna stop that. All right. I do want to see, is this actually doing anything? Let's, I just want to try this. Print yes. We're going to get rid of this one and just see if it's printing any yeses. No. Okay, so it's not getting here. This is wrong. How come that, do I have to do, it's like string? Do I have to make it a string to compare it? Do I have to do that? Or isn't it like toString or something silly? Is that what I have to do? No, because I don't know. What am I messing up? How come it worked when I did my little tester? And then what did I mess up here? Ay, caramba. F. I just want to... For handle and handle, if I just do this, print... No. Okay. Okay. Okay, I told you I was getting too cocky. I told you. I was getting... I knew it was going to come down to bite me in the butt in any minute. I'm close. I know I'm close. I feel close. Okay. Why does that not work? But it worked when I did it with two strings. Is it because they don't know that they're strings? Do I have to... if I just do... if follower equals, if I... Do I have to do toString or something silly? Is that all it is? Let's just try. Brand, but it is a string. It shouldn't matter. I'm just being silly. You're being a goof. Oh yeah, that doesn't even, that's... Oh yeah, brand, oh wait. Do I have to do this? Is it brand name dot toString? I don't remember how Python works, man. No. String object. Okay, so it is a string object. So, okay, that's good. But then why does this not work? Why? Check equals equals? Oh. Reread the sentence above. No, I don't want to reread. Damn it. Okay. Reread the sentence above example input output. Get average brand follows returns the average number of handles that contain the brand name across all the lists. Each list represents the audience of a single influencer. Oh. Oh, I'm so dumb. In my test, I did it as in. This'll be right, right? No? Wait, that did work before. Wait, why did it work in my test? Handles that what? What did I do wrong? Number of handles that contain... Okay, but this should work, right? I know I'm not going to get the answer right. I'm not worried about that yet. I'm just trying to figure out why this is all of a sudden not working. When I swear, when I did my little test run, it worked. When I compared two strings. Is it because a follower is not a string at this point? Oh, what have I done to myself? Contain? Nightshade, dude. You're too smart. Contain, right. So it doesn't have to be... I need to compare it. And I need to see if it's in that... If... Oh my god. Wait a... I am so dumb sometimes. HK Perf, what's up, man? Thanks for joining in. Quick tips to pick up. Just do it and be really bad at it. and don't be afraid to be really bad at it is the best tip I can give you. But boot.dev has been awesome for me. I really like it a lot. I haven't done it in like 6 months, which is why I'm trying to get back into it. But like when I do it on any sort of consistent basis, I always end up learning so much more. So it's just one of those things that like 100% just do it. Boot.dev has a bunch of free courses you can start with. I ended up buying the subscription for the year because I just, like I said, I really like it. But yeah, my best tip is just do it. And just know you're going to mess up. Or, I mean, maybe you won't. Maybe you'll be really good at it. I am terrible at it. And so I mess up a lot. Mostly because I get confused in my own brain and forget things like what I'm checking for. Even though before I started the assignment, I did a whole test, which worked perfectly in my test. And I was so confident after doing that test. But let's see if I can actually finish this now. So if brand name is in follower, total plus equals 1. And then now I just want to make sure that this gives me my total at the end. It should give me lots. And now I just have to average it, which is total divided by the length of all handles. Right? Oh, what did it not like there? Why is that failing? Expected. Oh, because I'm not returning it. That's why. Because I'm, again, being dumb. But I'm getting the right number, so that's all that matters. To me. That's that's what I figured. Never hurts asking questions. I definitely know I'm terrible already, so that's a great start. Yeah, man. Like, ask questions. Be terrible. Like, people... I remember, like... Okay. I feel like there's a very big difference between like what the Stack Overflow community used to be when it came to like trying to get help with coding and what every coder that I've come across on like Twitter or in person or Discord or anything, and the willingness to help. Anybody that I've come across that's like not, that actually like you talk to for more than a second has always been super willing to help me when I have questions. And yeah, just start. Like, this should work now, and we should be right. And we 100% wouldn't have got there if Nightshade Dude didn't keep giving me his little hints, pointing out that I'm being an idiot. because I get in my head, and I get confused, and I think about different things, and then I stop paying attention to what I'm actually doing. And I need those little prods sometime to be like, hey, man, what are you actually trying to figure out again? Don't forget. So having somebody who's willing to be like, hey, buddy, you're not doing the right thing is very helpful. Which is why I like doing it on stream, to be honest with you. I mean, one, I just really like streaming. I get a lot of energy and I find it very fun. But the other reason is people come in and they can help me. And instead of getting stuck on this problem and driving my head up through the wall, somebody will just come in and be like, hey, man, contain. And I'll be like, contain? I don't know what that means. What are you talking about? And they're like, oh, right. I was looking the wrong way. And now I need to change it and look the right way. So there you go. That's my best advice. I hope it's helpful. But definitely go do it. It's so much fun. Now let's actually do the whole submission. Make sure we get it. Oh, it's taking so long. We're running so much code. Yeah. We got it, baby. How did we do on the solution compared to what they said? What did I do differently? Oh, just naming mostly. Yeah, everything else was the same. Just naming convention. Oh, man. Remember when I was trying to look and see if the follower name was in the brand name instead of the brand name in the follower name? Even after I'd done a test to make sure I understood. And then even before that, I had done a test to make sure I understood how the formula worked. And then I used an equals instead of in because I'm an idiot. New challenge available. Big O with nested data interview. Oh gosh, that sounds terrifying. Well, we're going to keep going. We're going on to constants don't matter. Oh. Constants don't matter. Big O notation only describes the theoretical growth rate of algorithms. It doesn't deal with the actual time an algorithm takes to run on a given machine. As such, laugh aloud. I'm always looking for those "oh, I'm stupid" moments. Laugh out loud. So shout out to those watching not on YouTube. There you go. HK, what's up? Thanks for the "oh, I'm stupid" moments are great. Honestly, they're the best part. They're the thing. I don't know if anybody plays golf, but the "oh, I'm stupid" moments while coding feel the exact same as hitting a good shot on the golf course. Like, you hit that one good shot all day, you're like, I can't play this game. I'm so bad. I'm never playing golf again. This is terrible. What a horrible idea. And then you just knock that one shot and you're like, oh, I'm coming back forever. I am clearly the best golfer. That's how I feel every time I have one of those. Oh, I'm such an idiot. I got it now. And the good news is those happen a lot. You get to you get to have them basically all the time when you're starting, which is a lot of fun. Okay. As such, when doing big O analysis, we don't let ourselves get bogged down in details. For example, hold on one sec, sorry. For example, oh my gosh, I gotta close these things. Too many things, too many things. Okay. For example, take a look at the following functions. So print names once. Wait, did we already do this one? Okay, print names twice. As you would expect, print names one. Well, I should read this. For name and names, print the name, and then print the names twice. For name and names, print name. For name and names, print name. As you would expect, print names once will take half the time to run as print names twice. That makes sense. And in the real world of software engineering, doubling the speed is awesome. The funny thing about big O analysis is that we don't care. We're academics. Both of the functions above have the same rate of growth, O of n. You might be tempted to say print names twice should be O2 times n, but you'd be missing the whole point of big O. Constants affect actual runtime, but in big O analysis, we drop them because they don't affect how the runtime scales. So O n plus 3 is O of n. O2 times n is O of n. 10 times n squared is O of n squared. All right, that makes sense. Movie time. Let's see if we can answer the question before we do the movie. Which is a real category in big O notation? O of 5 would just be O of n, right? Which is a real category. O of 2 to the power of n. Okay, wait. Hold up. That's just O of n, right? Because O5, but that's not a category. Is this just a really weird question, or am I just overthinking this? Yeah, squared stuff is confusing, man. I get it. Okay, but hold on. I feel like the answer is 2. Because O... Or wait, was O2 to the power of n? We did this. Let's go back. I'd like to go back and look. Yeah. Oh, it's exponential. So wait, it is, but it's one of the ones that we said we don't want to do. So is that the real one? Whoops. Ah. So is it this one? Let's try it. Yeah. Okay. I forgot that one was the real one. Which is why I forget so many things while I'm doing this, because I just read that like 20 minutes ago. Okay, well, we got that right, but we're gonna watch the video anyways, just to see what old Lane has to say. Hold up, let me just pause and
Big
let's
O
watch this video.
notation only cares about the theoretical slowdown of an algorithm as its input size grows. It doesn't actually care about how long, like in seconds, this algorithm is going to take to run. So when I say if a linear time algorithm takes 1 nanosecond to run with an input size of 1, then it will take about 10,000 nanoseconds to run for an input size of 10,000. Like, that is true, but whether or not it actually takes 1 nanosecond on an input size of 1 or 1 full second on an input size of 1 is actually completely irrelevant to Big O. All we care about is the proportional change from one item to 10,000 items. We don't care about how long it actually takes. And when I say we don't care, I mean we don't care as computer scientists doing this theoretical exercise. Of course, as software engineers, we care. No one cares if the Big O of your website's load time is constant. If it actually takes 5 seconds to load, that's a terrible experience. So as software engineers, we do care about constants, but when we're doing Big O analysis, we don't really care. We just kind of brush it aside. We hand wave it away. Say you have a function running in production, and it takes 5 seconds to run on an input size of 10,000. Then you benchmark it again on an input size of 10 million, and it still just takes 5 seconds to run. Well, that's actually a constant time algorithm. The runtime isn't being affected by how big the input size is. But whether or not 5 seconds is actually tolerable by your users is up to your users, I suppose. But why this matters is that 5 seconds in Big O terms, we just don't care. We don't say, oh, it's order 5 because it took 5 seconds. We just say it's order 1 because it's constant. So that constant can always just be reduced to 1. Let's take a look at another concrete example. Here we've got a function called sum. Takes a list of numbers, iterates over all the numbers, summing the result as it goes, and returns it. This is fairly obviously an order n algorithm. Now this is interesting. Let's say we take another function. This one's called triple sum. It iterates over every item in the input once, summing the items as it go. But this time, it does it again and again. So just looking at this function, you can tell this function takes 3 times as long to run as the first one. Instead of looping over the input once, we're doing
5
it 3
seconds
times.
on.
So
if you have a website that takes 5 seconds, it's insane. But just to make sure that I'm understanding, because what he is saying is all that they care about when you're doing the analysis of speed is that it's the same. So you can. The fact that your website loads in 5 seconds could always be reduced, but the good thing, I guess, is that it will, regardless of how many inputs it takes, it's running at the same time. So you can, that sounds like it would be ideal. I mean, I don't think that's actually a real thing in the sense that if you, like, I can't imagine that happens very often, because if you had like an infinite number of inputs, eventually I would imagine something's going to break and slow down. But like but the key that I'm understanding is like when you're just looking at your analysis, you're just trying to figure out, okay, this algorithm is constant. So if I can reduce the 5 seconds down to 1 second or 2 seconds, then that won't change even if I have a ton of inputs. And I think, and that's what they're getting at.
The first algorithm is order n. Wouldn't this one be like order 3n? And the answer is yes, but we don't care. We're doing big O analysis. Constants don't matter. So that 3 just reduces to a 1, and we get order n again.
Got it. Yeah, so that's the same thing. So even though it's way longer, and that's what he's talking about, like for your actual users and for your actual applications that you're building, those things matter. But when you're just trying to see how the algorithm performs, it doesn't matter. It's kind of like physics. Always, you know, how do you measure a cow? And you start with a circle. That kind of stuff. Okay. Well, we already got the answer right, so that was good. Let's move on to the next one. And let's see, how many more? Oh, we're not getting, I don't even know if I can get through all of these today. Time flies, man, when you're doing this. Okay, let's keep going. Oh, hold on, sorry. Email, nothing. Okay, this is just another question. I'm pretty sure that's all the same stuff. It is, how would we reduce O2 times log of base 2 to the power of n? It would just be O, well, HK Perf, if you're still here, what do you think it'll be? I know my answer. I've already locked it in. I know what I'm picking. Anybody else have a thought? What they think it is? Here, I'm holding my answer up between 1 and 4 to the right-hand side of the screen. And I'm going to slowly bring it in. Slowly. Slowly. If you have a guess, put it in now. Put it in now. Ah, I'm going with 1. Boom. Champion. This is actually really interesting. This is the course I was so excited to take. And it has been living up to the hype for me. Okay, constants quiz. Consider the following functions. So sum of nums, total equals 0. For num and nums, total plus equals num. Return total. Double sum for num and nums. Double for fuck my life. Hey man, you tried. That's all that matters. You'll get it next time. But do you see what it? I'll go back. Wait, did you already pick 4 for this one, or are you picking 4 for the last one? Because it was, the reason it was 1 is because of what they were talking about, where the constants don't matter. And so there is, you weren't here for the beginning. So there is no, as far as I know, there's no notation of O log of n. And the log of 2 to the power of n has a constant in it, which means we don't care about it. So you got to get rid of it. And then the last one, O2, it's because it's a logarithmic O, which here, like I said, you weren't here at the very beginning. So we went through all these. So these are the different big O notations. So as soon as I knew that it had a log in it, I knew that the answer was going to have a log in it. But because the whole thing is about reduction and getting rid of all the constants, I figured it had to be the one that was what we learned in the beginning, because that's reduced with all the constants gone. And then 2 to the power of n doesn't have log in it, so that couldn't have been the answer. So there we go. Okay, so this one, what is the big, oh, hold on, I didn't finish reading. Total equals, so for double sum, so for each number in the list, you're doubling it, so you're adding it together, and then you're adding the double together. So what is the big O of sum and double sum respectively? Okay, I think, okay, what do you think this one's going to be? I feel very confident that I know which one it's going to be based on what we just talked about. And that is your guess number 1? Or is that your guess for the last one? What's your guess for this one? What do you think? 1, 2, 3, or 4? I hate allergies. I'm going to murder my sinuses. Okay, what do you think? What do you think? What are we thinking? I'm doing it. The answer, I am fairly confident, when you reduce it and get rid of all the constants, not consonants, that's language, it's going to be 3. Last one, this I'm going 1. I think it's going to be 3, because remember, you got to drop all those constants. So the n plus 2 doesn't matter. Even though double sum is going to take longer than sum, when you're comparing the big O notations, when you're looking at the algorithm speed, they're both going to grow through O of n. Ready? And now if I'm wrong, I will be a jackass for explaining it like I knew what I was talking about. Okay, here we go. 3. Oh shit, I didn't press the button. 3. We got it. We're getting there. We're getting there, man. But does that make sense now? So you're not comparing the 2 against each other. There's obviously the first one's going to take, with like real, in the real world, the first one, let's just say, is going to take 2 seconds, and the second one is going to take 10 seconds, but it doesn't matter because that's not what we're looking at, because the inputs are all going to grow linearly, right? That's the part I'm not 100. Is it linearly? Constantly. Oh no, linear. Yeah, we were right. Linear. That's what I was trying to say. We'll grow I can't say linearly. But that's how it will grow. So there you go. That's why it's reduced down to ON. Hey, I feel like I'm actually learning this stuff. See, this is what I'm looking for. Learning. Yeah, man. That's how I feel. Okay. I'm telling you, I will not deny that boot.dev is not cheap, like for the year subscription. Lane does some good discounts on it. But they do have lots of free ones that you can take. Like, you can take a lot of the free courses, and I would just do all of the free ones that you can and then if you decide you want to buy it, do it, because it's really good. I feel like I learn a lot when I do it. Lane spends a lot excuse me. Lane spends a lot of time making these courses really good courses and like really actually teach you things. So I would highly recommend it. Which is why I'm doing it. Okay, ignoring big O theory, which, oh, here you go. All right, let's see if we did learn HK. Ignoring big O theory, which function will realistically take longer to execute? What do you think? I'm excited to see what you think. I think we learned something today. 1, 2, or 3. Which one's going to take longer? I was debating it. The free stuff is meh. I only learned so much. I'm stealing your purchase. Yeah, that's fine. I did ask Lane a long time ago. I was like, hey, man, do you care if I stream this stuff? Because I just asked him on Twitter. I was like, do you mind if I stream this? Because I really enjoy it. And he's like, no, go for it. So there you go. Okay, what do you think? What's your answer? I'm waiting for you. I'm not going to say it. But we just discussed this together. So we should both get this right. I think we can both be fairly confident that we're right on this one. Oh, I forgot to turn the tunes back on. Hold up. Tunage back on. Depends on the optimizations that get done. Get out of here, Nightshade dude. We're talking about just as the question is written. Not anything else. Not any other real world. I gotta stop pointing. Pointing at you. All right. HK, I gotta put the answer up. Some? Which one's gonna take longer? Longer. It's all right. It was a good guess. I didn't say it. I didn't say it. What do you think? Quick. You got one last chance before I put my answer in. You're gonna get this right. I can feel it. I've got faith in you, man. Oh, I pressed it. I'm sorry. My finger slipped. I swear to God. Sorry. But double sum, remember? Because it's gonna take longer. Except depending on the optimizations you do. But in this question, 3, that counts. Your chat counts. We'll just say it was a delay. Okay. Next. Oh boy. Okay. Let's see. How many more of these do we have? I'm going to try and... I want to get this done. So 11, 12, 13. I think I can do 11, 12, 13 before I have to go. Then I got to go clean the house. And whoever's still in here, when we're done, we'll go raid somebody because it's fun. YouTube can't raid, but let's see if we can do these though. This might be difficult. These last 3 could end up taking me like 40 minutes each. So order of 1. Order of 1, excuse me, means that no matter the size of the input, there's no growth in the runtime of the algorithm. This is also referred to as a constant time algorithm. Oh my gosh, excuse me. In Python, a dictionary offers the ability to look items up by key, which is an operation that is independent of the size of the dictionary. Ah. There's ironic 5-second delay. Yes, it's 5 seconds. That's okay. It was a delay. You got it. But this is interesting. So there are order of 1 algorithms using dictionaries. Dictionary lookups are O1, which is one of the reasons dictionaries and dictionary equivalents in other languages are used all over the place. That makes so much sense. Interesting. Okay. Assignment. We need to be able to search our locked-in user base more quickly. Our users are complaining that the search bar is painfully slow. You'll notice that if you run the code in its current state, it will take a very long time. The find last name function takes names dictionary, a dictionary of first name, last name. So it's a key pair of first name, key value, last name, I'm assuming. First name, a string. If first name is a key in the dictionary, find last name returns the associated last name. If the key is not found, it returns none. Write the function so that it runs quickly. It should be O1. Nice bookshelf. Oh, thank you very much. I need to actually clean it up. I got a bunch of random shit up there. I am happy. I need it. So I never really like planned on streaming. So like obviously you can see that's a piece of glass behind me. And so it does shadows because I haven't set up my lights in a better way. But what cracks me up about it is it's like there's so much random stuff. I ran out of space and I don't know what to do with it, but I appreciate the compliment. I do love it. All right, we are going to make this better. So this is the one that it currently has. I'm going to try and run it and see how long it takes. Oh yeah, look at this. It's taking forever. Ridiculous. That's way too slow. I'm going to leave that in here though, just for while I do this. So write a function so that it runs quickly. It should be O1. So if first name is a key in the dictionary, find last name returns the associate. So wait, can't we just do return? Oh no, do I have to do an if? If there's a wait, can you just do return? There is like a way to do a return with an else, but I don't remember how to. I don't remember what those single line things are called. So we're gonna do it the slightly longer way. So if first name, what am I trying to do? No. I need to do for. Oh my gosh, what am I trying to do? I'm trying to do. I want to check. Now, this is where I need to just slow down because my brain is going stupid. All I want to check. I know I'm going to end up doing this. Names dict first name. I know that's what I'm going to end up doing. Oh, yeah. So wait. I just don't remember. I know there's a faster way to do like returning it as this or false. But this is basically what I'm doing. If the key is not found, returns the associated last name. Yeah, I think I have to go current first name, last name, and Dick. Name's Dick. What is this? If isn't that the fastest way to do it? If I just do this. Oh no, but I need the last name. I want it to return the last name, right? So that should return the last name, won't it? It just won't do the none. Hold on. Am I right here? What does that do? What does that actually return? Ugh. Well, that was good. But the only thing I'm worried about if I run the submit is that this doesn't have anything to return none. Or does it return none by itself? Is that just a property of doing a lookup? There's only one way to find out. We run submit and we see if it returns properly and I pass. Let's find out. I'm worried about the none part. Yeah, okay, shoot. That's what I needed to do. I knew there was a none. How do you do it? I don't remember how to write it in one line. So I'm just going to do this. It should... well, I thought it might. I'm going to do it as an if statement. Just if this, then return... Wait, is that what I want to do? No. That's not right. Or is that what I want to do? Yes, this is what I want. I just want to do return. Can I just do that? Will that return the right thing? Return none? Nope, that's wrong. I need to return the right thing. I need to... But what do? I'm just annoyed about the return. I knew the return none was wrong, but I don't know. I know there's a much faster way to do this. I'm just trying to figure it out. And I don't remember. And I could look it up, but I don't like to look it up. That's cheating. I need to just return... If it's in there, return... Could I do... Oh, there's a super simple way to do this. What? I know. I want to return the names. Dick. I don't know how this chat is blowing up. I found a gem here. Dude, my problem is... I appreciate that. My big problem is that I stream very inconsistently, and I'm trying to change that. So this is day 5 in a row, and I really am trying to get back into a habit of doing it consistently. So we will... Oh, is it that? Is it something like that? I'm hoping that I'll be able to figure it out. Nope, that's wrong. Is it just value? I know there's a way to do this. Oh, I'm so mad that I can't remember the super simple way to do it. I know that's not it. What does this actually... If name 6 first name... Oh, I'm just so annoyed because I know this is... I know that this is what I want to return. Oh, wait, I could do this. Oh, we could do this. Whoops. This, again, probably not the best way to do it. But... we can do this. If... not... Will this work? Or do I have to do equals false, maybe? Oh, yeah. So, if Again, I know this isn't the right way to do it, but I'm just going to do this thing. I'm just going to see if I can get this to work. Return none. Okay, it worked on that. Will it work on the full one? Come on, work with a none. Work with a none. Oh, because that's not right. If it doesn't return false, if it doesn't exist, what does it? What does? Okay, hold on. This is what we're gonna do. Ready? I just want to know what this returns if it doesn't have one. I know I'm wrecking my streak for this. But I don't care. I'm doing it anyways because I know this is gonna be wrong. But I just need to see what it does. It does. What does it print? Actual none. Okay, so it's printing that. So if it has it, it prints that, which is okay. And when it doesn't have it, it's an error. It errors out. So, oh, this is so stupid. Okay, I know at the end of the day, I want this to return. But I need to handle the fact that it might not be in there. Right? Because then I can't, then it doesn't error. I know the solution is going to be so straightforward that I'm going to be so mad when I see it. I can already feel the anger rising inside of me. No pressure, but I definitely recommend this to friends who also want to start coding. Yeah, please do. Like, I mean, A, definitely recommend to come watch, and then B, recommend boot.dev or anything else. It's fun. And hopefully we'll figure this out. Okay. I need it to, if it has that, I'm trying, what's the best way to write this? If it finds the key, so the problem is that it needs to be able to know, it can't error if the key's not in the dictionary. And the problem with writing it the way I've done is you're assuming that it already is there. So I have to do something that shows it's not there. But the only thing I can think of to do that is to do if first name is not in name. Like, I don't know how else to do it, but I know this is not the right way to do it. It can't be the right way to do it. Like, I know that's not the right way to do it. Does it still pass this? No, oh, that fails this too now. Return names. Now I've just totally bonked myself. Final last name complete in less than 50 milliseconds. So that, okay, so it's still fast. Why does that not work? If first name is not in... What was the original one? I'm going to reset this. Hold on. I'm going to copy this, and then I want to reset the whole lesson progress. Okay, so if current first name, last name, and names dict items. So yeah. If current first name. So it is looking. So if I'm on my lunch break at the moment, got back to it. Yeah, hey man, come back anytime. Like I said, I'm gonna try doing like Monday through Fridays, 3 p.m. Eastern Standard. So, whatever time. So that was like I started like an hour and 45 minutes ago. I'll be here. That's the goal. And if I don't show up one day, yell at me so that I come back. And I'm gonna try and figure this out and see if I can do it. If the key is not found, oh, I could just look at this. I bet this would tell me what to do. Let's do it this way though. Oh, does it want raised when a key yeah, it does I wonder if it wants me to actually handle the error, which I don't remember how to do because it's been so long. I don't remember how to handle a key error. I don't remember how to handle errors in Python. It's been way too long since I've done any Python. I know I could look all this up, but I wonder if that's what it wants me to do. I bet that's what it wants me to do, is handle the error. Oh. Should I ask Boots? Well, I could look in my spell book. Do I have key error? If whatever is none, do something, probably. Oh. You think so? So if I do... So if I just do this... Name... is none, then return... none, and then else we're just doing this. Oh. Is that what we're doing? Will that pass? Will that be fast enough? We're gonna find out. Oh! What did I mess up? If 3 p.m. or 3 a.m. equals perfect. Oh, Vancouver, Canada. Nice, dude. We only sleep if we get paid. Wait, what if I did... Can I do is not none? Nightshade, dude. I've lost my brain. I went too hard. I forgot. I haven't done enough Python or any coding recently, and now I'm flailing. It returns none. Oh wait, do I just do return? Is that it? Read the last two sentences. Damn it! If first name is a key in the dictionary, find last name returns the associated last name. Oh! Wait. Wait. So wait. So this function right now, as I have it written, is checking if it's none. Okay. If the key is not found, it returns none. Which is good. Final name returns these. What am I missing? What am I missing? I've lost it. I can't think straight. Will this work? Okay. So. What if it's none? Then it returns none. Right? What am I doing? What am I missing? What is not happening in my brain? I felt so confident for 2 seconds going into this, and then I lost it. If it's the key is in the dictionary, it returns the last name, which is what we want. But so this is... But then why doesn't return just work? Because if it returns none, shouldn't that just work? Like as a single line? Shouldn't that just work? Because if it doesn't find it, it should just return none. But when I did that, it didn't work. Wait. Let me read it one more time. You'll notice that I'm going to read the whole thing. I'm going to take my time. We need to be able to search our locked-in user base more quickly. Our users are complaining that the search bar is painfully slow. You'll notice that if you run the code in its current state, it will take a very long time. The find last name function takes a dictionary that has a key value pair of first name, last name, and a string, first name. If first name is a key in the dictionary, which we can check, then the function needs to return the associated last name. Do I need to do this as an else? That's what I thought. Okay, should be able to just return. Okay, so let me try this again because I swear to God, I'll have to go back in the tape. But I thought I did try this and it should have just worked. That, right? Return names, dick, first name. If this works this time, I'm going back in the tape because I swear to you, I swear I wrote this at the very beginning and it didn't work. So let's see what happens. I'm going to lose it if this works. I'm going to lose my brain. Yeah, see? First name key. That doesn't work. But that should work, right? Or is that just... Like, that's the part I'm not understanding. If I just... Now I'm just curious. Because if I just do this, what will it return? Will it return... Okay, so that put the name. That put the last name. That's what it's supposed to do. And then what did it do here? Oh, so it just... It's erroring out before... It didn't even print it. When the first name is this key one. Which isn't in the list. Try names dick.get first name. All right, let me try that. Return, whoop, rerun. Return names dick.get first name. Let's see. Okay, well that passed, so that's probably a good sign. Ah, that's what it was. Okay, so I think for my own ego, I would just like to say my thinking was in the right place. My memory of syntax was incorrect. And I'm going to use that mentality to make myself feel better. Because I feel like I knew what I was doing, except that was just 100% not understanding what I needed to do. I wasn't handling the error by doing it the other way. So, like, obviously I was doing it wrong. Obviously. Because when I did it the way I was trying to do it, it doesn't handle the error. Whereas the get handles the error. Dude, it's okay. Listen. If just like we got there, that's all that matters. I don't do Python either very often. This week is the most I've done Python in literally 5 months. So it's all good. But yeah, that was just stupid. I just couldn't remember. Like, what I was typing in was doing what I wanted it to do when it found the key. But the problem was I just forgot that you had to do something different if there's to handle errors. So what's the solution they did? Oh, see, he did just want me to handle the error. Now, two things. Your method is obviously even better. But, okay. Okay. My thinking was right. If I would have gone back and just looked a little bit harder on how to handle errors, I also would have got there. But, I mean, .get is way better as, as a solution. It's much shorter. Okay. Nightshade, we did it. I don't think I can finish these last two because I just realized that it's almost 5 o'clock. Which means we're going to finish this Big O analysis lesson, these last two, on Monday, if I don't sneak in and maybe just do them over the weekend for fun. But I think I got to go. I got to find more time to do more, even longer streams. But doing 2 hours is a good start for me. I feel very good. Nightshade, I thoroughly appreciate you swinging by and hanging out and helping me through my genius level coding here. And I hope, and everybody else that swung by, thank you. And I hope everybody has a good weekend. Who knows? If I find some time, maybe I'll do a quick surprise stream on the weekend, but I know we got a busy one with kids and stuff, so we shall see. But this is awesome. I'm having so much fun. I'm so glad to be getting back into streaming. Don't let me stop, because I will. Because my brain's like, hey man, you don't need to do this. You should just not stream and just do nothing. But it's like, no. I really like doing this. I want to continue to do this. So don't let me give up on it. This is kind of just a mental note to myself. more than putting any onus on anybody else to actually force me to do this. But I want to just keep doing it because I'm having so much fun. Okay. I am out of here. I got to make some short videos or something to put up on the old YouTube and drive that traffic. I hate how shorts do so much better than streams on YouTube. But what are you going to do? Okay. See you later, guys. Later, Nightshade. Talk soon, buddy.